Okay, so in this lesson, we're going to learn how to complete the square. Now, completing the square originated as a way to solve quadratic equations, another way to solve quadratic equations on top of the other like 10 different ways you know how to solve them. There's solving by square roots, there's factoring and then solving, there's using quadratic formula. So this is another way to solve a quadratic, and it's called completing the square. But what we're going to use it for is actually for the next unit, which is solving and graphing circles. Yes, we're going to leave behind algebra and the parabolas and lines to now different shapes like the circle. And completing the square actually helps us solve circle equations as well. So just in this lesson, we're going to learn about just how to complete the square. And in the next lesson, you will learn how to apply that to solving equations involving circles. So you may or may not have seen this already, completing the square. If you've been taught how to complete the square, you can skip this video, but for most of you, this is going to be a new concept. So basically, completing the square is a method to solve quadratics by forcing the equation to be a perfect square quadratic. And what I mean by perfect square quadratic, these are called perfect square quadratics because when you factor them, you get what multiplies to be 4 and adds to be 4. Well, it's 2 and 2. So what you end up getting is x plus 2 and x plus 2, or in other words, x plus 2 squared. So those are called perfect square quadratics because they're exactly the same thing. So you can write them as they're written right here. So another one is the next one here. So what multiplies to be 16 and adds to be -8? And if you were to factor that out and do your ABC and everything, you would get x minus 4 and x minus 4. Because -4 and -4 add to be -8, and -4 times -4 is 16. So you end up with just x minus 4 squared. And so the whole goal is to create a perfect squared trinomial, and that you can get it into this form right here, and that's the key, and that's what's going to help us with circles. So how do we do that? Well, quadratics are written in this form of sort of x squared, ax squared plus bx plus c. Now, in order to get it into a perfect square trinomial, we're going to remove the c and put in place this piece right here. So it's best if I just show you an actual example. We'll come back to this table here in a second, but we're going to look at this problem right here. So in order to create, and you can do this with any quadratic, some are easier than others obviously, but with a perfect square trinomial, you need to first move the c to the other side. So by doing that, you'll get r squared minus 6r. Now I'm going to leave a space right there where the c used to be, and now that equals positive 2. So now I'm in a position here where I can put whatever number I want right here. Now the number is key because it needs to make a perfect square trinomial, and how we do that is it's called they do b over 2 squared. Basically all you're doing is taking half of this number right here and squaring it. That's it. So if I just take half of my b and then square it, I'll have a perfect square trinomial. So if I take half of -6, that's -3, and square it, -3 times -3 is positive 9. Now, since this is an equation, in order to keep it balanced, I can't just add 9 to one side and that's it. I have to add 9 there, and I also have to add 9 to the other side as well. So, what does this do? It now creates for me a perfect square trinomial. So now if I look at this, okay, I have a perfect square trinomial. What multiplies to be 9 and adds to be -6? Okay, well, it turns out to be -3 and -3. So I end up getting x minus 3 and x minus 3. Because -3 and -3 is -6, and -3 times 9, -3 times -3 is 9. Now on the right side, 2 plus 9 is 11. Now x minus 3 and x minus 3 is x minus 3 squared equals 11. Now this might look familiar to you now because we actually solved these type of problems in the previous unit. We used solving by square roots. So we could use this form here to get rid of the square, giving you x minus 3 equals the square root of 11. Now 11 is a prime number, so I can't actually simplify that, but it is plus or minus, and then I just add the 3 over. So I get x equals plus or minus the square root of 11 plus 3. Now that's how we solved quadratics involving solving or completing the square. So what we're going to actually look at, we're just going to look at this part in red. We're not actually going to solve these because when we apply them to circles, you're not actually going to solve them. You're just going to get to this piece right here. So let's get some practice with finding this perfect square. So if we go up here to this table, this is going to be key. What number goes in for the C? What number right here makes this a perfect square trinomial? Again, that's that whole, and I'll see if I can put something here, yeah. So that is your whole b over 2 squared. Now, you don't have to memorize that. You'll actually memorize it pretty quickly. It's just half of b squared. I just take half of my b and square it, and that will end up being my c. So half of my b is 1. So I take half of my b is 1. So 1 squared is 1. So when figuring out what the c is going to be, it's going to be x squared plus 2x plus 1. And then the second one, half of my b squared. So, well, half of my b is 2. 2 squared is 4. So this ends up being x squared plus 4x plus 4. Third one, half of my b is 4, and I square it, which is 16. So x squared plus 8x plus 16. Okay. Half of my b in the fourth one is 5. 5 squared is 25. So x squared plus 10x plus 25. Okay, and that's how you create your perfect square trinomial. Now we're going to take that now and we're going to actually find what it is factored. So x plus 2, x squared plus 2x plus 1 actually factors. And the key here is this part right here. You know, half of your b, half of my b was 1. So when I go to factor this, it's just x plus 1 squared. Okay, and that's sort of the relationship here. Whatever half your b is, it's the same number that's in here. Because x plus 1 squared is x plus 1 times x plus 1. And if I factor that out, 1 and 1 is 2x, and 1 times 1 is 1. So it works out. Again, half of my b was 2, so I know that this is x plus 2 squared. Half of my b was 4, so x plus 4 squared. And you'll get real quick at this in doing this. Half of my b is 5, so it's x plus 5 squared. To prove that to you, you have x plus 5 and x plus 5. Well, if I FOIL this out here, you have x times x is x squared. You have x times 5, which is 5x, and 5 times x, which is 5x. 5x and 5x is 10x, and 5 times 5 is 25. So it works out. Okay, so last couple questions here. We'll try one on or together, one more together, and then you'll have one more on your own. So here is the extra questions. So, again, first step, okay, this is not a perfect square trinomial as it is. So in order to make this a perfect square trinomial, I actually need to move my c to the other side. So I'll have x squared plus 10x, leave some space, equals negative 28. Now I am free to choose whatever number I want here to make this a perfect square. Exactly what you were doing in the table up there. What is this value now? Well, we take half of our b and square it. Half of 10 is 5. 5 squared is 25. So I add 25. Now you have to be careful because this is a common mistake. Now whatever you do to one side of the equation, in order to balance it, if you do something to one side, you have to also do it to the other side. But now on the left-hand side, I have a perfect square trinomial. So if I fact this out, what multiplies to be 25 and adds to be 10 is 5 and 5. Well, that ended up being half of my b, remember? So half of my b was 5, so that's x plus 5 squared. And negative 28 plus 25 is negative 3. And that's as far as we're going to go, because it's really the only sort of application that we need here moving forward into circles. So that's the part we're going to stop. This would be your answer, using the difference of squares. Now go ahead and use that as a model for doing number 3. Okay. The one thing I'm going to warn you, though, is that the same thing applies that when we're working with quadratics. You have to make sure that if there is a GCF, that you take the GCF out first. That is a key. So this 2 is going to divide out. And that's going to be here. And actually, you don't even need the 2 there, or the parentheses. You're just going to divide everything by 2, and that'll be your new equation. And so now, use the difference of squares, pause the video, use the completing the square to get this into the answer that we need. Okay, so we're going to go through one more time how to do this. Remember, to create a perfect square trinomial, this is not a perfect square trinomial right now. So what we need to do is move the c over to the other side. So I get t squared plus 8t, leave a blank, equals positive 3. By doing that, it gives me the freedom to put whatever number I want right here to make this a perfect square trinomial. And how you get this number is you take half of b and you square it. Half of 8 is 4. 4 squared is 16. So this is a positive 16. Now remember, what you do to one side, you also have to do to the other. Now, this is now a perfect square trinomial that I can factor. What multiplies to be 16 and adds to be 8 is 4 and 4. Just so turns out that that was half of b. It's always going to be half of b. So half of b was 4, so that is x plus 4 squared equals 19. And that's as far as I want you to go, because that is the only part that is applicable to circles. So that's it. There's no work or assignment that necessarily goes with that, because this is not actually a standard or outcome. This is going to help us when solving and graphing circles, which is in the next video. Thanks.